Okay, so we're now recording. So in this question, you asked, construct a normal distribution curve and label the horizontal axis, then answer each question. So this is a worksheet on the 689599.7 rule. So as we know, 68%, middle 68% is when you're within one standard deviation of the mean, right? So when you're middle plus minus one standard deviation. So if you're told the mean is 30,000 and standard deviation is 2,000, and again, it's the mean plus or minus one standard deviation. So I'm just going to add 2,000 to 30,000 and subtract 2,000 from 30,000. So I'm going to say it's 32,000, or I'll go lower, 28,000 to 32,000. And there we go. Now the middle 95% is plus or minus two standard deviations. So of course I have to 4,000 subtract 4,000. So I'm going to have 26,000 or 34,000. What percent of tires will have a life that exceeds 26,000 kilometers? Well, 26,000 will be over here. And remember, this was this portion right here was 68%. So if you do a little bit of math, right, 95 minus 68 is going to be 27. But if you divide that by 2, you get 13.5. So this is going to be 13.5 right here. And that's going to be 13.5 right here. But the bottom line is that this is the middle 95%, which it does add up to. So it means that these portions here that's going to be 2.5%. And this portion here will also be 2.5%. So the percent of tires that have a life that exceeds 26,000 is actually 97.5%. That's because 2.5% is to the left, or less than 26,000. And remember, 26,000 was two standard deviations, which is right there. So that's how you would answer that one. If a company produces 2,000 tires, how many tires do we expect to last more than 28,000 kilometers? So that's one standard deviation. So that's going to be, you have the 16% here you have to take away. So it'd be 84%. They expect to last more than 20,000 kilometers. So that's, remember, 20,000 kilometers is right there. And you're going to remove that 16% from 100%. So that's how you would go about those problems. Any questions about number one? And if you have any questions, feel free to speak in your microphone, or you could type in the chat. So that's how that's done. And again, I'm recording this, so I strongly suggest when preparing for the test on the 22nd, which is Thursday of next week, it might be good to watch this to get that review. Number two, the shelf life of a particular dairy product is normally distributed with a mean of 12 days and a standard deviation of 3 days. Okay. So about what percent of the products are between 9 and 15? Well, again, that's plus or minus one standard deviation. Again, that's going to be 68%, because again, you have a mean of 12 and 3 days. Between 12 and 15 days, that's going to be this portion right here. So actually, let me do a selection and get rid of that, because I like using that diagram. It's actually very helpful to have that diagram. There we go. So between 12 and 15 days. So remember, mean was at 12 straight up, and that was at 15. So it's going to be all this right here. So that's going to be 34%. But what percent of products last 6 days or less? So 6 days, remember, that's going to be two standard deviations. That's 9 and that's 6 right here. And less than that, that's going to be 2.5%. And last 15 or more days, so 15. So you're in this region, which is going to be 16% again, because 84% was to the left of it. And last 15 or more days is 16%. So those are the answers for number two. All right, let's keep moving here. Number 3, a lineup for tickets to a local concert at average waiting time 20 minutes at the standard deviation of 4. 4% of people in line wait for more than 28 minutes. So again, it's 2 standard deviations. I'll just use ST here. So that percentage is going to be 2.5%. If 2,000 tickets were buyers were in line, how many of them would expect to wait for less than 16 minutes? So that's going to be 1 standard deviation, actually negative 1 standard deviation. And so that's going to be the bottom 16%. Remember again, here's your normal curve. That's the mean. That's minus 1 standard deviation, plus 1 standard deviation. That's 68% right there. So it means that you're going to have 16% here and 16% here, because you have 68 in the middle. So it's just very simple math. And you're waiting for less than 60 minutes, which is 1 standard deviation less than the mean. So there you go. On a recent math test, the mean score was 75, the standard deviation was 5. Mike got an 85. So obviously he is 2 standard deviations above the mean. So it's positive 2 standard deviations. So that's going to be over here. That's 1 standard deviation is 2 standard deviations. Remember, that's going to be 2.5% here. So he's 97.5 percentile. That's his first percentile. So he's the top 2.5%. So that's number 4. Let's look at number 5. If an Oreo factory, the mean mass of a cookie is given 40 grams for quality control, standard deviation is 2. If 10,000 cookies were produced, how many cookies were within 2 grams of the mean? Well, that's just 68% again. So again, this is plus within 2 grams. That's plus or minus. Yeah, go ahead.
Oh, for number 4, isn't it 95%? Because it's 85, right? So it's 2 standard deviations.
Yeah, but his percentile is going to be, so let's look at that one more time. No, it's 97. I'll explain why. So that's the 50th percentile right there, right in the middle.
Mm-hmm.
And your 2 standard deviations above. So now this is going to be 84th percentile right here.
Mm-hmm.
And we probably should do it this way too. It's good. It's a good perspective, and that's 16th percentile because you have 32 here and 32 here. Then what happens is that this is going to be 97.5. That's going to be 2.5. So when you're within 2 standard deviations, which I'll shade in yellow, when you're within 2 standard deviations, you're actually the middle 95%. So it means that in each of these tails, you have 2.5%. You have 2.5% in this tail and 2.5% in this tail. So when you're exactly two standard deviations above the mean, you're at the 97.5 percentile.
Yeah, I got it.
Yeah, okay. Cool. Yeah, that's a little weird. So you have to kind of just think about the symmetry.
Yeah.
That goes with that. So okay, cool. So anyway, that's the middle 68% for 5A, plus or minus 1 standard deviation. So you're just going to multiply this by 0.68, which should be 6,800 cookies. And if cookies are rejected, they weigh more than 44 grams or less. So that's basically outside of 2 standard deviations. So if you're greater than 2 standard deviations or less than negative 2 standard deviations. So that's going to be 5% of the cookies that are in those. So that's negative 2 standard deviations, 2 standard deviations. There's the middle. So you're going to be at those 2 tails. So that's 5%. 5% of 10,000 cookies will be 500 cookies, I think. Yeah, so 500 cookies get rejected. For 6, the speed of cars, blah, blah, blah. You guys get the point. Okay, so it's going to be kind of redundant now. Average less than 85, so that's the bottom 2.5%, because that's minus 2 standard deviations. Police car stop, they're going 105, so you're now 2 standard deviations above the mean. How many cars would they stop? So that's going to be 2.5% again, plus 2 standard deviations. The mean life of a battery is 50 hours, the standard deviation is 6, the manufacturer, blah, blah, blah. we'll place that last less than 30. So that's minus 2 standard deviations. Again, 2.5%. A grading scale is set up for 1,000 student test scores. Assume that the score is normally distributed with a mean of 75 and standard deviation of 15. So this is the mean. And that's minus 2 standard deviations. So remember, you're going to do that 34% and that 13.5%. So it's actually 47.5%. So let me draw that out because that was a little strange. So here's a normal curve. There is 75, and your standard deviation is 15. So you're gonna have 60, and you're gonna have 45. So this right here is 34%. And we were talking about that this was 13.5%, and that was 2.5%. So that's how, if you add it up, of course, you get 50 to the left of the mean. But to be between 45 and 75, that's 47.5%. If 60 is the lowest pass score, how many students are expected to pass the test? 84% passed. Because 16% was less than 60, because 60 is minus 1 standard deviation. Hopefully you guys are okay there. Let's keep moving. Number 9. The monthly income of 5,000 workers at the Microsoft plant are distributed normally. Suppose the mean monthly income is 1,250 and the standard deviation is 250. Let me think here. So yeah, if you earn 1,500, earn more, so that's plus 1 standard deviation. So you're going to be the top 16% of earners. What percent earn less than $750 per month? So that's minus 2 standard deviations. So that's 2.5%. You're on the far left. What percent earn between 750 and 1,500? So that one's a little bit weird. I think that's going to be 81.5%. I'll show how I got that. So again, draw a normal curve. So you want to visualize this. The mean is 1,250. 1 standard deviation, of course, is 1,500. Above, one below is going to be $1,000 because remember, standard deviation is 250. And then 2 standard deviations below will be at 750. You want to be between 750 and 1,500. So you're looking, boom, 34%. Boom, 34%. And finally, that's 13.5%. Simple math added up, you get 81.5%. And the what percent of workers are less than 1,750? So 1,750 are like 2 standard deviations above the mean, but you got to be less than that. So 2 standard deviations above the mean. If you're higher than 2 standard deviations, you're 2.5%. So less than that would be 97.5%. Make less than that. So hopefully this drilling kind of helps. Makes you feel a little more comfortable with standard deviation. Any questions about that? Nope. Okay. So I'll stop this recording and I'll start a new one. The next part. So this is what we called homework 11 solutions. Let me stop that.